Hello, in this lecture, we're going to learn about sandwich rule. We call it squeeze theorem, or sometimes we call it pinching theorem. Before learning sandwich rule, we need to learn this theorem, which says that if there are two functions f of x and g of x, where f of x is smaller than or equal to g of x, for all the x in the common domain, where x is near a except possibly at a. It means x should be near a but not exactly equal to a. And the limit of f and g both exist at a. In that case, by theorem, limit x approaches to a f of x will also be smaller than or equal to limit x tends to a g of x. So in a common domain, if f of x is smaller than or equal to g of x, then the limit x tends to a, x approaches to a f of x will also be equal to or smaller than limit x tends to a g of x, where x is near a, remember, and not exactly a. Okay, let's move to the sandwich theorem. Now, the sandwich rule is used to confirm the limit of a function via comparison with other functions whose limits are known or can be easily computed. So we find the limit of a function by comparing two functions. For example, there are three friends h of x, g of x, and f of x, and they are moving in a queue and they're going somewhere, walking, and they're going somewhere. And after some time, we call h of x and ask about his location. And he says that I'm near CN Tower, Toronto, but I have not reached CN Tower, but I'm near CN Tower. And then we call f of x and we ask him about his location at the same time. And he says he is also near CN Tower, but not exactly at CN Tower. Now, by the location of h of x and f of x, we can easily conclude that g of x is also at the same location. Because they are moving in a queue and g of x is between them, so and if h of x and f of x the same location, then g of x should be there. So by comparing these two, we can find the location of g of x. Similarly, we have three functions here: f of x, g of x, and h of x, for all x in common domain and near to a. f of x is smaller than or equal to g of x, and g of x is smaller than or equal to h of x, where I told you that x approaches to a and not exactly a, such that the limit x tends to a, f of x is equal to limit x tends to a, h of x is equal to L, where L is some value. So by the sandwich rule, we can say that by comparing, because uh, at a the limit of f of x and h of x gives you the same result, and g of x is between f of x and h of x. By comparing and by sandwich rule, we can say that limit x tends to a, g of x is also equal to L. So this is how we compare the limit of g of x by the limit of h of x and f of x. Now this rule is used when the limit of a function is not possible to find by limit law. For example, if you have limit x tends to 0 x square sine 1 by x. Now the limit of this function at 0 by limit law is not possible. So we use sandwich rule to find its limit at x at 0. So we know that sine function exists between -1 and +1. And now we multiply x squared to all the expressions. So it gives you x squared. And here also it is x squared. Now we apply the limit. If x tends to 0, x tends to 0 negative x square, limit x tends to 0 x square sine 1 over x, and limit x tends to 0 x square. So if limit x tends to 0 negative x square, we know that at 0 we can substitute and it gives you 0. So if the function smaller than or equal to x square sine 1 over x gives you the same result, so by sandwich rule we can say that the limit x tends to 0, x square sine 1 over x is also equal to 0. Okay. Uh, let's see another example. If 4x minus 9 smaller than or equal to f of x smaller than or equal to x square minus 4x plus 7, and for all the x which is smaller than greater than or equal to 0, we need to find the limit x tends to 4 f of x. And here we're going to use sandwich rule, and we apply x tends to 4 limit in all the terms. So that's limit x tends to 4 f of x, limit x tends to 4 x square minus 4x plus 7. So we'll compare the limit x tends to 4 of f of x to this and this. So first we find limit x tends to 4, 4x minus 9, which gives you 16 minus 9, which is 7. And limit x tends to 4 x square minus 4x plus 7, that's 4 square minus 16 plus 7, which gives you the same result 7. So if they both tends to 7 at limit x tends to a, so by sandwich rule we can say that limit x tends to 4 f of x is equal to 7. And let's see another question which says that the expression is limit x tends to 0 x to the power 4 cos 2 over x. Now the value of cos lies between negative 1 and positive 1, and we multiply x to the power 4 to all the terms, so it gives you x to the power 4 cos 2 by x square, x to the power 4, and then we apply the limit here, which is limit x tends to 0 minus x to the power 4, limit x tends to 0 x to the power 4 cos 2 by x, limit x tends to 0 x to the power 4. And now because negative x to the power 4 and positive x to the power 4 at 0 tends to limit 0, and this function is between them, so by again by sandwich rule we can say that limit x tends to 0 x to the power 4 cos 2 by x will be equal to 0.